thought we'd just do one more titration calculation video. I thought we'd do this one because the stoichiometry is not a one-to-one relationship. If we look here, we've got sulfuric acid in this equation, H2SO4 is sulfuric acid, and it's reacting with sodium hydroxide. And this is a 1-to-2 ratio. So some of the previous videos we've done have all been 1-to-1 ratios. So I thought we'd just quickly do this one. Let's look at the question. It says a titration was carried out 25 centimetre cubed of 1.25 mole per decimetre cubed sodium hydroxide solution. Right. Just before we read any further, I always think it's a great practice just to put this information on the equation next to the reagent. So 25 centimetre cubed, that's the volume. So let's write 25 centimetre cubed above sodium hydroxide, and 1.25 mole per decimetre cubed of sodium hydroxide, that's the concentration. So 1.25 mole per decimetre cubed. All right, so that's the sodium hydroxide we've got, NaOH. It was titrated with sulfuric acid, that's the H2SO4, titrated against the sulfuric acid. The volume of sulfuric acid required to neutralise the sodium hydroxide solution was 22.6 centimetre cubes. Let's write 22.6 down there. That's the volume of sulfuric acid. It asks us to calculate the concentration of sulfuric acid. So the concentration, question mark for the concentration there. So we've got all the information for sodium hydroxide. We've got a volume for sulfuric acid, but we need the concentration. So, straightforward calculating quantities calculation. Remember, there's 3 stages to all of these. First one is moles. Then we need stoichiometry. And then we're going to do moles again. So, 1 moles, 2 stoichiometry, 3 moles. Okay, so what we do to start with, we calculate the number of moles of this substance that we have all the information for. Now, if we look at the equation here, we've got all the information we need for sodium hydroxide. The question mark is on the sulfuric acid, so that will go over into the stage 3 one. The stage 1 moles is going to be this one here. We're going to work out of sodium hydroxide. Now, the moles equation for solutions is volume divided by 1,000 multiplied by concentration. Okay, that equals moles. Volume, 25. Divided by 1,000 to turn it into decimetre cubed because it's given in centimetre cubed. Multiplied by the concentration, 1.25. So if we do not remember this formula here, we cannot do this calculation. So if you haven't remembered that, just write it out 15 times until you've learnt it. There's no point in drawing a calculation until you've learned that. So let's put that into the calculator here. So 25 divided by 1,000 multiplied by 1.25. Let's put into a decimal. 0.03 equals 0.03125 moles. Now remember, do not round in the middle of a calculation. Right. So we've now found we've got the moles of this. So we now come to the stoichiometry stage. Now remember I said this isn't as straightforward as some of the other ones because it's not a 1-to-1 ratio. So let's just write out the bit of the equation we need, and that's that bit there. Let's not worry about the other bits on the right, the products. We don't need those with this for this question. Now this tells us 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. And we've just calculated that we've got 0.03125 moles of sodium hydroxide, so 0.03125. Okay, so 2 reacts with 1. Okay, 2, bigger number, 1, smaller number. Remember, there's no 1 before the sulfuric acid in that equation. We never bother writing the number 1 in equations. If there's no number, it's a 1. So 2 reacts with 1. 1 is smaller than 2. 1 is half of 2. Okay, so therefore this number of moles of sodium hydroxide is going to react with a smaller number of moles of H2SO4. It's going to react with half the number of moles of H2SO4. So we need to divide that by 2 to halve it. 2 reacts with 1, therefore that is going to react with half as much. So this number over here divided by 2 to halve it. And now we have an answer of 0.015625 moles of H2SO4, sulfuric acid. So I'll just write it there if it helps you to see. So 1 reacts with 2, therefore 0.015625 is going to react with 0.03125. Okay, so that is the most difficult stage, I think, in these calculations. So we've now got the moles of sulfuric acid. Okay, that number there is going to come up now to stage 3. Okay, because if we look at the formula up here, the equation up here, we have 22.6 centimetre cubed of sulfuric acid. We now have the moles of sulfuric acid, which is 0.015625 moles. So if we use this equation again, over this side, this moles equation again, we've got the moles, we've got the volume, we can just rearrange it to make concentration the subject. Okay, so I always believe in formula triangles. Okay, let's just put a quick formula triangle over here. I've always rearranged with formula triangles. So we've got volume divided by 1,000 multiplied by the concentration. So remember, formula triangles have a divide and a multiply. Okay, so the volume divided by 1,000 is going to go there because we've got multiply. So there's the multiply, and there's the volume divided by 1,000. Multiplied by the concentration, and that's going to equal moles. Moles has to go on top. Okay, so we've got the moles, which is 0. Let's just do another triangle here and put these in. What do we say moles was? Moles was 0.015625. So the moles is going to go on the top. 0.015625. The concentration, we're trying to find the concentration if you remember. It says calculate the concentration of sulfuric acid. Concentration is the question mark. And we've got the volume now of 22.6. Now we need to divide that by 1,000 to get it into decimeter cubed. 22.6 divided by 1,000. Okay. Now what we're going to do essentially is put our finger over that. Okay, and it's going to be that's what we're going to have to do. Let's work this one out first just to make it a little bit easier. So we're going to do moles equals, what do we say it was? We said it was moles equals, we're doing concentration, aren't we? Concentration, let's write this equation out now. Concentration equals moles, so finger over concentration, moles divided by volume divided by 1,000. Can we see that over there? Volume divided by 1,000. So let's just, I'm just bracket that because we'll work that out first. Put these numbers in here now. So the moles was 0.15625 divided by 22.6 divided by 1,000. Okay, let's just simplify that and work that out first. So 0.015625 divided by 22.6 divided by 1,000 equals 0.0226. 0.0226. Right, so now we just need to do that last sum and we shall have an answer. So 0.015625 divided by 0.0226 equals 0.69. 137, and we can round now. So we started with, if we remember here, 1.25 mole per decimeter cubed, so we went to 2 decimal places, so I think we can do that to 2 decimal places there. The number after the 9 is a 1, so we're not going to round it up. And we're going to have mole per decimeter cubed, and it was of sulfuric acid, H2SO4. And there is our answer.